This lecture will talk about different online services that your Raspberry Pi or any device really can interact with and get services from. Request services, get responses from them. Web-based services. So by this we mean services in the cloud, right? So some service that is run on remote servers that are accessible through the network. These are services that typically your Raspberry Pi doesn't have the ability to do, so maybe it's too computationally intensive, the tasks that it performs, or maybe it just doesn't have the data that it needs or something like that. So runs on a remote server, so there's some remote server, say from Facebook, some remote servers, and they accept requests from clients. So a client like your Raspberry Pi will send a request, and then they'll get a service. And they interact typically using HTTP messages. These are web-based services, right? So the interface is going to be HTTP. Right. Now, the HTTP messages are constrained, but they are HTTP formatted messages. So here's a picture of what something might look like. So you got some device. I'm drawing I have a little cell phone icon there, but it could be it could be a Raspberry Pi or whatever it is. It makes a request to some servers at Google Maps. Say those are servers at Google Maps. Give me a map of UCI. Now, of course, it doesn't just say give me a map of UCI. There's a formatted message there that's sent. And then those servers receive it, they get the map, and they send a response which contains the map or data to find the map or something like that. So that's the idea, to have these services running remotely. And it adds a lot of power to your system, right? Because a Raspberry Pi alone can only do so much. But if you want to be Internet of Things, and this thing needs to communicate with the Internet and access these remote services. So this is a very common thing that IoT devices can do, is sort of access bigger services provided by servers somewhere out there on the network. So, Applications Programming Interface, or API. API is the shorthand for it. So an API defines a communication interface between programs. So when we're talking about these web-based services, the API defines the format of the messages that have to go back and forth from client to server. Now, these are web-based services that we're talking about. So these are all HTTP messages. But the API is going to define the content of the HTTP message. So, for instance, what information should be in each header, right? Which headers are required? What should be in the payload if there's a payload? Things like that. They have to be defined by this API. So the API just tells you how, client, if you want to make this request for this data, you should format a message in this way, an HTTP message in this way. If you want to request this type of data, you format it in this way. And they tell on the other side, they say, look, when you receive the response back, you can expect the data to be in this field, and this other type of data is in this field, and so on. So it tells you the format of the messages that go back and forth between the client and the server. So request-response messages. It also defines the legal sequence of messages if a sequence is relevant. So what I mean by that is that a lot of these protocols are stateless. That is, you send one message, you get one response, and there's no memory of a previous sequence of things that happened before, right? But sometimes there are message sequences. So you send one message, and then you get this response, and based on the response, you send another message. So there can be a sequence of messages. And if that was the case, if you had an API like that, if you had a protocol like that, then the API would have to specify that. It would say, you send this message first, and then if you get this response, you can either send this or that message, something like that. So that would be a more complicated API, but that's all within the scope of what you'd call an API, to define the legal message formats and then the sequences, if they are sequences. So for example here, say this is my mock-up of Google Maps API. Now, this is not a Google Maps API, but this is the idea. Say Google Maps API, I want to get a map of some place. So maybe they say, look, you send an HTTP message. It's got to be a GET message, and after the GET, you've got to put in under Maps. You put in the name of the place that you want the map from, and it will go and find that map for you. And then you give the HTTP version or something like that. This is overly simplified, but that's the idea. It tells you how you compose the HTTP message in order to get the result that you want, to get the service that you want. Now, API is one term. SDK is another term that is related in this context. Software Development Kit. Now, there's a broader definition outside of network protocols, but in our scope, Software Development Kit and SDK, it's a set of tools to support the use of an API, put it like that. Now, that can mean different things. Typically what it means is a bunch of library functions, okay, that support the use of the API. So an API just tells you the format, what the messages should look like and how they should be formatted. The SDK is typically a bunch of library functions that adhere to that API. So what that means is that the programmer doesn't need to know the details of the API because the SDK acts as an interface for him or her. So for instance, if you want to send a message to get a map from Google Maps, right? One way would be just know the API that I showed in the last slide, and then you create a string that looks like that, and then bam, you send that. Or if you had an SDK, the SDK might have a library function in there that says get map, right? A get map location or something like that, and then it just takes one argument, which is UCI, the name of the place you want. And then that function, it's the job of that function to actually create the proper request message and send it out. So it makes it easier. If you have an SDK, you have these library functions where you don't even have to know the details of the API. You just call the library functions, and they handle all the details. So SDKs are good. Sometimes API and SDK are used interchangeably, okay? So watch out for that. Sometimes when you're looking up API, SDK, when you want an SDK, you look up API and you end up finding an SDK. So the difference between APIs and SDKs sometimes is blurred, but roughly the API defines the interface and the SDK is a bunch of tools, maybe just library functions, that help you use the API. So as an example, so here's my example that I was walking through. The API says, look, here's the format of a get message to get a map from Google Maps, let's say. And the SDK instead provides you with this get map function that takes care of it and formats the message and sends it for you. Something like that. So that's roughly the relationship. Thank you.